So what do you notice about this line right here? What kind of line is that? Linear, yes. By definition, linear is a line. That's good. Like what shape is this? Like what direction does it go? What kind of things can you use to describe this line? And I guess what the word I want you to say actually starts with an H. Horizontal, right? This is a horizontal line. Can you have a horizontal line that crosses the y-axis at 5? Yeah, absolutely, but it's not the parent function. This one is the parent function, okay? This horizontal line crosses the y-axis at 1, all right? So first of all, we need to talk about the domain and the range. Have you ever heard of domain and range before? What do you know about the domain?
It's how far it goes, like on the x-axis.
It's the x's, right? How far it's on the x-axis. So we're going to label that right over here. That's the x's. What do you know about the range?
The y.
It's the y's, okay? Now, when we talk about domain and range, when we talk about domain specifically, we need to say how far to the left does it go and how far to the right does it go. Obviously, we care about the middle, right? But to begin with, we're going to say how far left and how far right. Okay? So if I'm looking at this graph right here that crosses the y-axis at 1, how far to the left does it go? What do you think? It looks like it goes to -10, right? But what's on the end of that line? An arrow, right? So what does that imply? That it doesn't stop. Exactly. So how far left does it go? All the way, right? How far to the right does it go? Also all the way. When you were in Algebra 1, you learned a certain way to write domain and range. And that way was called inequality notation, okay? In Algebra 2, we definitely have to know inequality notation, but we also need to know something called interval notation. So when we write domain and range, especially on this worksheet today, we're going to use both so that you make sure that you know what both of them are and how to use both of them and the fact that like one compares to the other, okay? So we know that this goes all the way to -infinity to the left and all the way to +infinity to the right, okay? And the way you know how to say it is what? Do you remember how you would say it in Algebra 1? Would you say all real numbers? Do you remember that? Okay. Now, do you actually want to write the words all real numbers, or is it okay if we use the symbol? Symbol's fine with you? Do you remember what the symbol is?
It's like a line on the top and then like one.
So it looks like an R, right? But it's a fancier R.
Yeah.
So instead of coming down once, you actually come down twice and then draw an R. Are you okay with knowing that that means all real numbers? Yes? Okay, awesome. Then we can use it. We can only use it if you understand it, right? Okay? Now, before I go any further, I have to I'm going to put my lid on my pen because we gotta talk for just a second, okay? Because I have to contradict myself, okay? And I have to say to you that, guys, there's no such thing as -infinity. It's just infinity. Infinity or infinity. So why in the world did we write -infinity? Well, for us, it's a notation. -infinity means we're talking about to the left, right? We're talking about to the negative direction. There's not -infinity, it's just infinity. We write -infinity as a notation to tell ourselves we're talking about in the negative direction. Does that make sense to you? Okay? So, now take my pen back off and keep going. Okay? Now, what do you think we talk about for range? If we talk about left to right for domain, what do we talk about for range? Up and down. So can I argue with you about that one? Is that okay? And it's more like a technical issue, arguing like you're right, you're not wrong. How if I say that? Okay? Because anytime we're talking about domain and range, we always have to talk about negative to positive, right? Left to right. And if you think about it that way, can you think about how you have to change the words that you used? How do you have to think about range if we're talking about negative to positive? Not up and down, but down to up, right? I know that feels weird to say because you don't say down and up, right? You say up and down. That's what we say, right? But if we're going to be real specific and real purposeful in our language, instead of saying up and down, we're going to say down to up because we know we have to go negative to positive, okay? So we're going to say down and up. So how far down does this horizontal line go? To 1, right? How far up does it go? Oh, also to 1. So it's just 1. That's the only range value that's allowed, right? Notice that I put it in brackets. I didn't put it in parentheses. Why didn't I put brackets around the infinities? Do you know where the end of infinity is? Yeah, me neither. I don't know where it is. And I can only put brackets around it if I know that it contains all of it, right? It contains all of 1. 1 is part of my answer. I don't know where the end of infinity is, so I can't use a bracket there. Whenever I use infinities, I'm going to use parentheses, okay? All right, so this is interval notation. These two are interval notation. This is an equality notation for domain. So I need you to know what inequality notation looks like for range. And it's kind of tricky. Not tricky, but tricky if you know definitions, right? What does inequality mean? Not equal, right? Except inequality notation for this range is y equals 1. That seems a little counterintuitive, right? But that's just how we write it. Okay, that's just like the name of the form. It's kind of an unfortunate name, but we're going to just get over it and go on. Are you okay with that? Okay. Notice that I put no maximum or minimum. Why is there no maximum or minimum? Is there a highest point on this line? Is there a lowest point on this line? No. Also notice that intervals of increase or decrease. If I move from left to right across the graph, is this line increasing or decreasing at all? No, it's staying what? Constant. Oh, guess why it's called constant? Oh, there you go. Okay. Now this last section down here, I think first I need to translate it for you from algebra to English. Can we do that? It says as x and then a right arrow and then negative infinity. So what it's saying is as x is going to the left, right? As my x's are going to the left, what does f of x mean? Y. It means y. Do you guys know that? F of x is the function notation for y, right? So as our x's on this graph are moving to the left, what's happening to the y's? Well, what are the y's every point on this line? It's 1, isn't it? So it doesn't matter how far we go to the left, what is the y going to be? 1. What happens if we go to the right? As x goes to positive infinity, as we're moving to the right on this graph, what's happening to the y's? It's still also 1, yeah. Okay? Now sometimes the numbers we put into the table matter because I want to get a good picture of what the graph looks like based on just the table. This one doesn't matter because no matter what x value I choose, what's my y value going to be? 1, right? So I could just go ahead and choose the ones right around the origin, the x values, -2, -1, 0, 1, and 2, because I know no matter which x values I choose, my y values are going to be 1. Now, somebody please tell me the x-intercept of this graph. Where does this graph cross the x-axis? It doesn't. And then somebody tell me where this graph crosses the y-axis. So I have to argue with you again, right? When am I arguing with you today? When you're wrong? Have I argued at all when you were wrong? No, you just weren't like exactly right? You weren't wrong, but I needed you to correct a little bit of purposeful vocabulary, right? Okay? So isn't an x-intercept and a y-intercept, aren't those points? And if I say what's the y-intercept and you say 1, is 1 a point? So where's the point that the line crosses the y-axis? 0, 1. Absolutely. And I know that seems picky, and I guess technically it is, but I don't care. It's right? Okay? All right, any questions about constant? We good? All right. Let's look at the next one. Anybody have any idea what the name is? Yep, that's absolutely correct. And why is it linear? Yeah, it's a line, right? It's a line, so it's called linear. But this one was linear, wasn't it? Yeah, it was like a special kind of linear, right? Because it's horizontal, it's called a constant. Okay? All right, so looking at the graph, let's talk about domain. How far to the left does it go? All the way, right? How far to the right does it go? All the way. So my domain in interval notation is negative infinity to infinity. And the way we say that in inequality notation is all real numbers. What about the range? How far down does it go? All the way. How far up? All the way. So negative infinity to positive infinity, or all real numbers. Okay so far? All right, what about symmetry? I think I forgot to talk about symmetry up here because I already gave you the answer. Why does this one have symmetry over the y-axis? What if I fold this paper on the y-axis? What's true about the graph? Isn't it right on top of itself? So what does this one mean? A couple different ways we could talk about it, right? If I held on to this right here and spun my paper, isn't that the same graph as if I had it like this? So do you see the symmetry about the origin? Yes? Is there a maximum or minimum? I mean, I know I already gave you the answers, right? I did that on purpose, but do you understand why there's no maximum minimum? There's not a highest point, there's not a lowest point, is there? Okay? What about intervals of increase or intervals of decrease? Where do I start when I'm thinking about intervals of increase or decrease? Left side of the graph, okay? And then I move my finger. Am I increasing or decreasing? Wait, like the whole way I'm increasing? Do I ever decrease? So when I'm talking about intervals of increase or decrease, I need to write a word out here to the side so you remember what we're talking about. This is a domain issue. We're only talking about the domain when we're talking about intervals of increase or decrease. So I'm only caring about the x values. So if you're telling me that I increase the entire length of the function, then my intervals of increase is the domain of the function. Does that make sense? And if I'm increasing everywhere, where am I decreasing? Nowhere, right? So there's no intervals of decrease for this graph. As the x's are moving to the left, where are the y's going? Down, right? How far? All the way, right? So what do you think I put right here? Negative infinity, yeah, absolutely. And x is moving to the right. As x is moving to the right, what is happening to the y's? They're going up all the way, right? So infinity. Very good. Do you think it matters what values I put in the table for this graph? Do you think if I choose the middle couple that it would give me a different picture of the graph than if I pick some down here and some up here? Or will I get a good picture no matter where I put it? Probably no matter, right? So let's go ahead and choose these. Because they're kind of right near the origin, right? Okay? Now, if y equals x, shouldn't these two be the same? Shouldn't these two be the same? And so on? What's the x-intercept of this graph?
0, 0.
0, 0. Very good. Very good. We remembered that it needed to be a point, right? What's the y-intercept? Wait, you already just said that the x-intercept was 0, 0. So tell me what the y-intercept is. It is, right? That's a little trick question, isn't it? Okay? If it crosses at the origin, the x-intercept and the y-intercept are the same, and they are the origin, aren't they? Okay? Any questions so far? So far you haven't seen anything new, have you? Okay? So let's go here. Anybody know what this is called? What shape is it? All right, tell me what it's called.
Absolute value.
ABSOLUTE. Value. How are you going to remember that this is called absolute value? Well, what does this letter start with? I mean, what letter does this word start with? V. And what does this look like? A V. Absolute value looks like a V, right? What does absolute value mean? In math, what does it mean to find the absolute value of something? It means how far is that thing away from 0? It's a distance, right? Okay? So, let's look at the domain of the graph. How far to the left does it go? All the way? How far to the right does it go? All the way. So, negative infinity to positive infinity, or all real numbers. What about the range? How far down does it go? Oh, 0. How far up does it go? Okay, so this is a little different, right? It starts at 0 and goes all the way up. Starts at 0 and goes all the way up. What did I say goes around the infinities always? A parentheses, right? Parentheses will always go around the infinities, but something different goes around the 0 this time. It's not a parenthesis. Sometimes it will be a parenthesis, but not for this parent. Okay? This parent, it's a bracket. Just like we used on this one over here, where we had brackets around the 1 because the 1 was included as part of our range. Isn't the 0 included as part of our range? Doesn't our graph touch the 0? Yeah? When it does, it's a bracket. Okay? Now, how does that look? That looks like this. Y is greater than or equal to 0. Okay? Now, maximum. Why does it say none? Is there a highest point? No. What about a minimum? Oh, there is a minimum, isn't there? What's the lowest point on this graph? 0, 0. It's the origin this time, isn't it? Now, remember when we're talking about intervals of increase or decrease, we're talking about domain. So we start on the left, and we draw with our finger, and we decide, are we increasing or decreasing? So let's start right here. Are we increasing or decreasing? And then, so we have some of each this time, don't we? Okay. Where are we increasing? On the right hand of 0, right? This is increasing, isn't it? Now, can I stop you for just a second? There's sometimes people get confused by this because they're like, look, it's increasing. It's going up. Except what did we say? Where do we have to start? On the left, right? We have to start on the left and come to the right. And if we're doing that, you can clearly see that this is decreasing, can't you? Okay? So the only place we're increasing is right here on the right-hand side of 0. So it starts at 0 and goes to infinity. But I need you to be really, really careful here. Okay? Because when we're talking about intervals of increase or decrease, we're always going to use parentheses. Now you need to understand as a math teacher, I hardly ever use always and never. Because there's almost always something else that could happen, right? But when we're talking about intervals of increase or decrease, why would we not use a bracket on 0? Look at this. is that point increasing or decreasing? It can't, right? The point doesn't increase or decrease, does it? But after 0, is that increasing or decreasing? That's increasing. So when I look at the 0, it is not increasing at 0 because 0 is a point, and it can't increase at a point, but after 0. So not including 0, but going all the way to infinity. Those are both parentheses because I can't include the end point. Does that make sense? Okay? So where is it decreasing? The left side of 0. Does that make sense? Okay? So how am I going to write that? Yes, but I need you to be careful because sometimes people want to say 0 to negative infinity, right? And that's another place that, like, you're not wrong, but you're not exactly right either. Because how do we always think? Least to greatest, right? And if we're talking about least to greatest, we have to go negative infinity to 0. Does that make sense? Yeah? Okay, good. So, as we're moving to the left, as x's are moving to the left, what's happening to the y's? They're going up how far? All the way. As we're moving to the right, what's happening to the y's? Also up, right? All the way. What about the table? Do you think there's important points that we need to have on this table this time? Oh yeah, this time yeah, right? Because I could choose 1, 2, 3, 4, 5, and those are perfectly fine points. Those are perfectly fine x values on this graph, right? But will I get a true picture of the graph if all I put is points right here? No. So what point do I think is the most important of this graph? The vertex, right? This point right here, 0, 0. How about if we put that in the middle of our table so that I make sure to have points on either side?
Any sophomores that don't have Chromebooks, please go to the library. Thank you.
So I need points on either side of the 0. So it's going to turn out to look like the same table we've done before, but this time it has a reason. Does that make sense? Because before it didn't matter. This time it does matter, but it just happens to be the same points as before. So if I go left 2, how many do I have to go to find my y value on my graph? 2. If I go left 1, how many do I have to go to find my y value on my graph? 1. Guys, another way to think about it is how far is negative 2 away from 0, right? Because I put a negative 2 in right there. How far is negative 2 away from 0? It's 2 spaces away from 0, right? How far is negative 1 away from 0? 1. How far is 1 away from 0? 1. And 2? 2. Okay? What's my x-intercept for this graph? 0, 0. Good. And what's my y-intercept of this graph? Also 0, 0. It's at the origin, so they're the same, aren't they? Okay. All right. What about the next one? So far, I guess the last one you might have seen, right? If there was extra time in Algebra 1, maybe they showed you absolute value, or maybe they just showed it to you because it's a cool one, because it looks like a V, right? This will be the first one you've never seen before. Okay? So first of all, let's talk about the function itself. F of x or y equals 1 over x. So visually, if you look with your eyeballs, what does this function right here, not the graph, what does this function look like to you? A number over another number? What does that look like? A fraction, right? What's another word for fraction that starts with an R? Ratio, right? Do you know that? Guess what this graph is called? It's called rational. It's a ratio. One number divided by another number. Okay? Now, let's look at the graph. What do you notice about the graph? For the record, there's like 84 things you can notice about the graph. So notice something about the graph. What do you notice? There's 2, right? So she said there's 2. I'm going to correct her vocabulary just a little bit, and I'm going to say there looks like there's 2 parts. Is that fair? That's almost what you said, right? Okay. There looks like there's 2 parts. How many graphs are there really, though? Just 1, but it looks like it has 2 parts. Absolutely does. Okay. Anything else you want to notice about the graph?
It goes infinitely up and it goes infinitely vertical and horizontal in both ways.
It goes infinitely vertically and horizontally both directions. Good observation. We're going to do this one a little backwards. Where's the x-intercept of this graph?
There's not one.
There is not one. Good. Where's the y-intercept of this graph?
There's not one.
There's not one. That's going to be something we talk about. Well, let's go and talk about it right now, right? Where's the important part of the information? If we're filling this table, where's the important part of the information? Is it also around the origin? So let's go ahead and put 0 in for x and do 1 and 2, or -1 and -2, and then 1 and 2 down like this. What if I put x into my equation? 1 over -2. What is 1 over -2? -1/2? Yeah? What if I put in a -1? What's 1 over -1? Isn't that just -1? Yeah, absolutely. What about 1 over 0?
Can't divide by 0.
You can't, can you? You cannot divide by 0, can you? That is undefined. It also tells you why you don't have an x-intercept. We're not allowed. We're not allowed to have an x-intercept for this problem. Okay? If you think about it, it also tells us why we can't have a y-intercept for this problem either, because I would have to be able to put something into the x value right here for the equation and get a y out. If I put in a 0 for x, I can't get a y. That's undefined. But what can I put in for x that will give me a 0 over here? Nothing. That explains our 2 intercepts being none and none. Okay? So what if I put in a 1 right here? What's 1 over 1? And what's 1 over 2? 1/2. Okay? So we did that one in a little bit different order. You okay with that? If you're not, that's fine. I just need you to get over it. It's fine. Okay? All right? All right, let's go talk about the domain. Do you think that this domain might be a little bit different than what we've been working on before? Because of the fact that it doesn't cross an axis, right? Okay? So how we have been thinking is how far to the left and how far to the right. Well, how far to the left does it look like it goes? All the way. And how far to the right? All the way. So it's not the ends that we care about. It's toward the middle, isn't it? Okay? If we're talking about the x's, it goes all the way to the left, and as we're coming this way, what happens right here? Does it ever get to 0? No, because 0 is undefined, right? It can never ever get to 0. Now, I'm going to be honest with you guys. This is something that's difficult sometimes for my human brain to make sense of. It's very difficult to think that this line right here, or this curve, is going to get closer and closer to 0 and never touch it. Because eventually you think it's eventually going to get there, right? But you can always get closer without touching. I can't draw that for you, right? Because I'm a human. And even computers can't even draw that for you. Because it's hard to imagine, right? Really, the only place you can figure it out is in your brain, in your imagination, right? But once it gets to 0, it never touches 0. But think about when it starts again on this side by 0, it's still not touching it over here, but then it goes to infinity. So our domain looks like this. It starts at negative infinity and goes to 0, but it doesn't ever touch 0. And then, first of all, that's a U. It stands for the word union, which in this kind of notation means and then. It starts again on the other side of 0 and goes to infinity. Does that make sense? That's the notation that we use to say everything but 0. So when we write it in this other notation, what we say is all real numbers, but x is not 0. And what I need you to realize is that those two things mean the same thing. Okay? So what about the range? How far down does it go? And then how far up? But what happens right here? Same thing, right? Negative infinity to 0, and then again from 0 to positive infinity, which is everything, but this time y is not equal to 0. Y because we're talking about range, right? X when we're talking about domain, but y when we're talking about range. Symmetry is around the origin because I could spin it like I did a minute ago. There's also a line of symmetry at y equals x, which is my linear parent function, because if I folded it that way, like that, right, wouldn't it be right on top of itself? Okay? There's no maximum or minimum because it keeps going in both directions. Where is it increasing? It doesn't. There's nowhere that's increasing. So if there's nowhere that it's increasing, where is it decreasing? Everywhere, right? It's not a constant where we have none and none. If it's not increasing anywhere, then it's decreasing everywhere across the whole domain. As x's are moving to the left, where's the y going? As x's are moving to the left, where's the y going? What's it getting closer and closer to? 0. Yeah, absolutely. As x's are moving to the right, what's the graph doing? What's it getting closer and closer to? 0. Just from the other side of 0, right? Okay? Any questions so far? All right, what I need you to do before you come tomorrow is I need you to attempt this top one on the next page. Not the whole next page, just the top one. I need you to attempt that. Do I expect absolute perfection on their very first homework of the year?
Yes.
No, absolutely not. For the record, I will never, ever expect absolute perfection because I can't let you expect absolute perfection from me because I will fail you every time. Okay? So please attempt this top problem right here before you come tomorrow.